In this question, we're told that a ball is thrown vertically upwards with a speed u meters per second from a point P at height h meters above the ground. Okay, I'm going to start with a diagram straight away. Let me see what's happening. So here's the ball, and it's been launched from a point h meters above the ground. Just going to indicate that to remind myself this unknown distance is h. Let's draw the flight path of the ball. So this is the path it will take, and there's the ground if it at all comes to hit the ground. Okay, continue reading. The ball hits the ground 0.75 seconds later. The speed of the ball immediately before it hits the ground is 6.4 meters per second. The ball is modeled as a particle. Okay, lots of information, some things that we would have assumed anyway. Show that u equals 0.9. Show that the initial velocity is 0.9. Okay, let's collect the SUVAT variables for what we do know. So, SUVAT and T. We don't know the displacement or the initial velocity, but the final velocity, we were told that just before it hits the ground, it has a speed of 6.45. We need to be very careful here and make sure we make that negative for the velocity because it's moving in the opposite direction to our original movement. So the velocity here should be negative 6.45. Acceleration, as always, is going to be negative 9.8, and we know that the time when it hits the ground, 0.75 seconds later. The formula to use here to find u is going to be v equals u plus at. Just substituting in the numbers that we have, and we want to find u, so we'll rearrange to make u the subject. I haven't touched my calculator yet, but I'm writing out the calculation I will type in. U equals 0.9, and this is exactly what we were asked to show. So, very happy that we're going to get all of those first 3 marks. Part B of the question asks us to find the height above P to which the ball rises before it starts to fall towards the ground again. Okay, the wording here is letting us know that we're talking about a portion of the journey up until it gets to its greatest height, up until it's instantaneously at rest. And we know sometimes the wording is find the maximum height above the point it's projected from. We just need to make sure we're always thinking what part of the journey are we referring to. So we're going up to this point, and implicitly we've been given some new information. We know that at this point the velocity equals 0. So the final velocity here we're going to set to 0. Unknown displacement. Initial velocity of 0.9. Final velocity of 0. Acceleration is negative 9.8. And we do not know the time. We're not looking for that. The formula, v squared equals u squared plus 2as. And as we substitute into that, we can rearrange to find s. So 0.9 squared over 19.6. And into our calculators, to 3 significant figures, 0.0413 meters. So that's a very short height. My diagram wasn't to scale, but just taking in that this is only 4 centimeters. It only went up by 4 centimeters before it started to head back towards the ground. Okay, part C of the question asks us to find the value of h. To find h, we're going to revisit the original variables or the original journey, which is the entire journey to the ground. We're looking for the displacement. So an unknown s, initial velocity we now know, 0.9. Final velocity we also know, negative 6.45, negative 9.8 for the acceleration, and 0.75 for the time of flight. Just to stop at this point, if the question hadn't told me to show that the initial velocity was 0.9, I would try to avoid using that in any of my calculations. Because if it's something I've calculated, we don't know for sure that it's correct. And I may be able to pick up some method marks, but maybe not all of the accuracy marks. So good exam habit is to try and use the values that were given to us in the question, so we know for sure those are correct. Avoiding using u leaves us with s equals vt minus half at squared. Substituting in our numbers, and we get negative 2.08. Well, if that's the displacement, that's not quite the answer for the height. Height is a scalar and will always be positive. So the height is 2.08 meters. That's the original height that the particle was projected from.